This is Ajay Kumar, an entrepreneur, engineer, sportsman, nature lover, and educationist. I belong to the city of Patna, which is the capital of the state of Bihar, located in India. I am founder and currently director of a high school named Gyan Ganga Global Academy, situated in a beautiful rustic setting of Samastipur, Bihar, India. This school has ambition to provide quality and holistic education to village kids with world-class infrastructure, loving and learning teachers to help the students become noble citizens of the world. I started my 20 years of career as an engineer from IIT Dhanbad, worked at companies in India and USA, earned my master's and MBA in US, then contributed as finance professional and management consultant in global companies. I traveled across multiple countries in 4 continents and interacted with a variety of people and cultures. I enjoy the company of kids, students, people, plants, nature and life. I love working and innovating in the education sector, teaching kids and learning from them as well. Thank you. Welcome. We are going to talk about today exponents and powers. We have learned in lower grades addition, subtraction, multiplication, division. Exponents is another operation that we can work on the numbers. So exponents are expressed for large numbers in a very short space. So if we multiply a number, the same number many times, then we can express that in exponent terms. So if we have 1000, then we can say 10 into 10 into 10, which is 10 into 10 into 10. So 3 times 10, so we say 10 and then to the power 3. Okay, and that's how we express large numbers. We can say a million as 10 to the power 6, a billion 10 to the power 9, and so on and so forth. Similarly, we can say 2 to the power 2, 2 to the power 3, and 3 to the power 2. So when we raise to the power, as we can see in the paper, that 10 to the power of 3 is 10 into 10 into 10, that is 1000. So here 10 is raised to the power of 3. Sometimes people confuse and say, hey, 10 into 3 is 30. So, but that you cannot do. If you are saying 10 and power 3, then it is 10 to the power 3, which is 1000, not 10 to the power 10 times 3. Okay, 30. Here 10 is the base. 10 is the base and 3 is the exponent.
Okay.
Now moving on. Yeah, now moving on. If we say, let's say another number, 2 to the power of 3, then it is 2 into 2 into 2, that is 8. Okay. If we say 3 to the power of 2, then it is 3 into 3, which is 3 twice multiplied, and 3 times 3 is 9. Okay. Similarly, if we can say 2 to the power 10, so it's a big number. So 2 10 times. I'm not going to write 10 times, but I know that for the fact, and you can check later on, that 2 to the power 10 is 1024. So that's a big number and expressed in such a small space, right? Now
I have a question.
Yeah, please.
If we have a fraction as a base,
Right.
how will we do that?
Right. So if you have a fraction, so you can write this exponent as a general form, that any number, positive or negative, raised to the power of n is a multiplied n times. Multiplied how many times?
N
times, and that is called a to the power n. Now here the number is a whole number, right?
Okay.
If we are saying now that the number is fraction, as you are saying, p by q, where q is not equal to 0, right? Because if we divide by 0,
It is
then
n
we,
different.
right. So as we have learned, so p by q to the power of a square, if we say, then we just say numerator and denominator, separate it out, remove the bracket and separate it out and say, okay, p numerator to the power of square and denominator to the power of square, and then do the operation. Okay.
Okay.
So let's say for an example, if we have 2 by 3 and if we to the power 2, and when we say to the power 2 we say square.
Okay.
Okay.
Yeah.
So 2 by 3 to the square, then we just separate out the numerator and the denominator and say 2 square divided by 3 square, and 2 square is 2 into 2, which is 4, and then 3 into 3, which is 9, so 4 by 9. So that's what is it clear?
Okay. Yes.
If we raise something to the power of 3 and the base is whatever number and the exponent is 3, then we say q. If the exponent is 2, so let's say 2 to the power 2, then we say square, 2 square. Okay. And if we say 3 to the power 2, then say 3 square. Okay. Now can you believe that why this has come? So it's a very interesting 2 square. When we say square, what does it come to your picture? So the square means
Square.
then we are drawing a square where the two sides are equal for a quadrilateral, right?
Yes.
So all sides are equal, and when we say square means its area, right? So the side is 2 and we say, hey, this is a square. So the area is 2 square, which is 4, right? Area is 4. And similarly, if we say cube, so what is cube? 3 to the power 3 is cube, is the volume of a cube, and that's where the number is coming from, that it is a cube. Okay.
Okay.
So now let's make a cube, and then we say, okay, this cube has sides 3 and 3 and 3, and the volume is, what is the volume? So the volume is 3 to the power raised to the power 3, which is 3 times 3 times 3, and that is 27. So that is what is cube, volume of a cube. Okay, and that's why we just call it cube. So these names coming from. Okay, not it. So we discussed that something raised to the power of something. So a raised to the power of n is the exponential form.
Okay. Now I have a question. What if the base is negative? What happens then?
Okay, very good question. So if the base is negative, so let's say choose a pick number -3, and we are putting a base square. Okay.
Okay.
So -3 we have to multiply 2 times. So -3 times -3. And let's see, 2 minuses becomes positive, right?
Yeah,
Plus. So 2 minuses, when we multiply, they become positive. So minus minus plus, and then 3 times 3 is 9. So 9. Just write that. Now if we, interestingly, if we raise this -3 to the power of 3, an even odd number, then we have to multiply -3 3 times. So -3 times -3 times -3. So 3 3 and 3 3s are 9, 3s are 27. However, the sign is now positive and positive is negative, and negative is positive, and then times negative, which is negative.
Okay.
So if we raise to the power of even number, then you have a positive result. If you have raised negative number raised to the power of odd number, then you have a negative result. Okay. Now I want to move on. I know you have you may have more questions, and I will let you do some of these exercises that you have done already. Laws of exponents. So there are some laws of exponents. How the exponents, there are 2 exponents, how do they interact with each other? Okay. So let's say we have here 3 to the power of 5, and then we say, okay, then 3 to the power of 4. Okay. Then what should we do? One way is to say, okay, these are 2 numbers now. This will result 3 5 times you have to multiply, and 3 4 times you have to multiply. So what will happen? You have to multiply 3 5 times, right?
Yes.
3 times 3 times 3 times 3 times 3, and then also multiply 3 4 times. So basically what you are doing is that 5 times and 4, 9 times you have multiplied, and we can write 3 to the power 9. Empirically you can see that what you are doing is that base is remaining same, but the exponents are just getting added. So 5 and 4 is 9. So we have now a law, which is if there is a to the power m into a to the power n, then we just say same base and we add up the exponents. So a to the power m plus n. That is the first law of exponents. If we have the same base, we just add up the exponents. Moving on, if we, in the same way, if we have two exponents, same base, and we have one exponent on the as a numerator and another term as a denominator to the power n, then what we do is that, let's say by example, 3 to the power 5 divided by 3 to the power 4. So we have same base, right?
Yes.
So we multiply 3 5 times, okay, and then divide by 3 4 times,
and the 3's get,
so you can see that these 3's are getting divided, so you are getting 1. You can just cancel them, and what is left is that only 3, right? So 3, which is 3 is 3 to the power 1, right? So what actually is coming through is that a to the power, what you have done is 3 to the power 5 minus 4, and that's what the second law is, okay? That a to the power m divided by a to the power n, if they have the same base, then you just subtract the powers, okay? So this becomes a to the power, this becomes a to the power m minus n, okay? Do you have any question right now?
Yes. I have another question involving negative exponents.
Oh, so if you have negative exponents, very good question. This is very much related to what we were talking about, that if you have same base but one is numerator and another is denominator, then what we should do. So what we did is, like, if we have a to the power of m and a to the power of m, so same base but different powers, exponents. So what we did was a to the power of m minus n.
Okay.
Now let's assume that here what happens if m is greater than n. So let's say m is 4 and n is 3, then it's a bigger number, right? So
yes.
a to the power of 1 it becomes. But think about the opposite. If m is now 3 and n is 4, so m is smaller than n, then what happens is that a becomes m minus n becomes negative, right? Then
yeah, that's exactly what I'm asking about.
Right. So in that case, a 3 minus 4, and a becomes to the power of minus 1, right?
Okay.
And how do you express this thing then? In the reverse way. So what happened? A 3. So what we could do reverse way is that, what was this? A to the power of 3, and why did we bring this thing negative? Because it was down, right?
Down.
So that's what we have to do. 8 power 3 divided by 8 power 4, and then we did is 8 power 3 minus 4, right?
Okay.
So what we do, 8 power minus 1 means on the top 8 power 0 minus 1, right?
Yes.
So on the top 8 power 0, and bottom we say 8 power 1, and so 8 power 0 becomes 1 and 8 power 1 becomes 1. So 8 power minus 1 is 1 divided by 8.
A to power 0. How did that become 1, sir?
Okay, yeah, that's a very good question. So, it's not very intuitive, right? If we put something 8 power 0, what does this mean? We said that a to the power of n means, when we said 8 power n means 8 is multiplied
like
how many times?
N
N times. So if we say a multiplied 0 times, that doesn't make sense, right?
How do we do it?
How do you do that? So very good question. Okay, there are two ways that we can think about it. So one is that 8 power 0. How did 8 power 0 come into picture? So one is that 8 power 0. How do you get 0? When you subtract one number from the same number, then you get 0, right?
Yes.
So 8 power 0 we can write a to the power of 2 minus 2, right?
Yes, okay.
Okay.
How
And
does this help us?
right, and so now we can write the reverse way as we did 8 power m divided by 8 power n equal to, if we have same base, we say 8 power m minus n, right? So we have same base, we can express this into fractions.
Okay.
So what we do, a to the power of 2, and then we say divide by 8 to the power of 2, right?
Yes.
So a square divided by a square. If we have the same number on the top and one, so as you saw, one on the top and the same number is on the bottom, so what happens, they both cancel out, and what is remaining is that you have 1.
Okay.
Right? An example is that, you know, if you have 8 to the power 0, you can say you can say 2 to the power 0, which is 2 to the power 3 minus 3, right?
Okay.
So 2 to the power 3 divided by 2 to the power 3, they both cancel out, and what is remaining is 1. Another way to see this is that, you know, let's look at this way. 3 to the power 3 is equal to what? You say 3 into 3 into 3, right? We can also say, hey, we can just multiply this by 1 and the result is same.
Yes.
Okay? Now we can say, write the same way, 3 square is equal to 3 into 3, and then we can add 1, right? Similarly, we can say 3 to the power 1, and so now what's the next in the logical sequence that you see? 3 to the power 3, 3 square is written this way, 3 to the power 1 is this way. So if I say 3 to the power 0, then what do you remove?
The 3.
3, this 3. So what is left is 1, right?
Oh, okay.
And so that's how you can express 3 to the power 0 is equal to 1. So this is on a mathematical way, this is the intuitive way that you can say, hey, 3 to the power 0 is equal to 1. Okay?
Yes.
Now we saw laws of exponent. One is 8 power m into 8 power n is 8 power m plus n. Second one, 8 power m divided by 8 power n is equal to 8 power m minus n.
Okay.
Right? And the third one is, if we have something, let's say 8 to the power m, and then we raise that another power to the power of n, then what happens? So the law of exponent says that, you know, you just multiply these together and remove the bracket. So 8 to the power m into n, which is 8 to the power of mn. Okay?
Okay.
And how do you do that? So let's say we have 2 to the power 3 and we raise that to the power of 2. Then what happens is that 2 to the power 3 is what? 2 into 2 into 2. Good job. And so that is 8 to the power of 2, which is 8 into 8, which is 64, right?
Okay.
And how do you express 64 in the base 2? So we say 2 to the power of 6. As you can see, 3 into 2 is 6. So that's how you express this law of comparison. Okay, exponents.
Any other laws?
There are other laws as well, but I think we will pause that here right now, and I will let you understand these better, do some exercise, and then we will move on to the next law and next exercise. Okay?
Okay.
Thank you guys.